Welcome back to All This Math. This is Professor Parker. You see I got my Fisk University sweatshirt on. Fisk University is a historically black college located in Nashville, Tennessee. Probably one of its most famous alumni is William Edward Burghardt Du Bois, better known as W.E.B. Du Bois. And I want to recommend this book, which is entitled The Education of Black People. It's a compilation of about 10 speeches and lectures and essays that Du Bois wrote. Actually, about at least 3 of the lectures or speeches that are in here, he delivered at his alma mater, Fisk University. So I highly want to recommend this to you, The Education of Black People. It talks about just what the title says, the education of black people in the early 20th century. And a lot of the issues that Du Bois exposed and addressed and offered solutions for still need to be addressed today in 2023. So I highly recommend this text. And, a lot of the other work that Du Bois wrote, actually, because, a lot of people have a lot of opinions about Du Bois, but I wonder how many of those people actually have really read his work. So definitely familiarize yourself, love him or hate him, agree or disagree. That's cool. But definitely read his work. And this is one piece of literature I definitely recommend, The Education of Black People. All right, now let's get into this. So we're going to do some factoring, right? That's our instructions. We're going to factor this expression. We have 196n squared minus 144. So we're going to factor that. Now, what I'm going to do with this particular problem is I'm going to factor it 2 different ways because we got a couple options. And I like problems like this, and I like to create video content about problems like this where I get to expose the fact that in mathematics, you always have options. There is hardly ever going to be just one way to do a problem. There might be a more efficient way to do a problem based upon how the problem is set up or how it looks, but you always have options. Even if you might like doing a way that's more difficult or more challenging or takes more time and more steps, you might just be more comfortable with that. And if you want to do it, by all means, I say, go ahead, do your thing. But I'm going to do this 2 different ways because traditionally the way I teach students is whenever your job is to factor, always try to pull a GCF out first. Always try to pull a greatest common factor out of the expression first. And then if there are other ways to factor, try those methods in order to factor completely. But with sometimes, if you got a binomial like this, and both of the terms are perfect squares like we have here, because if you know your perfect squares by heart, you know that 196 is just 14 times 14. You know n squared is a perfect square because anytime you got a variable with an exponent, whenever your exponent is an even number, write this down, whenever your exponent is an even number, you know that term is a perfect square. So n squared, n to the 4th, n to the 8th, n to the 20th, n to the 100th power. Notice all them exponents was even numbers. So therefore, all those terms are perfect squares. All right. 144 is a perfect square because 12 times 12. The back of your composition notebook. The biggest number in the multiplication table in the back of the book is 144, bottom right corner, because 12 times 12 is 144. All right. So these are both perfect squares. So we could jump right into difference of 2 squares approach, right? Dots method, I like to call it. Difference of 2 perfect squares because you got a difference. Because of the minus sign, remember, make sure there's a minus sign there, not a plus sign. If it's a plus sign, it don't work. Don't fall for that. Don't fall for the okie doke. Your teacher might try to give you 2 perfect squares with a plus sign in between and see what you're going to do. See if you're really paying attention. Make sure it's a minus sign in between. If it ain't a minus sign, you can't do that method. All right? You got to pay attention to details. That's another thing math teaches you, to pay attention to details. All right? So you got a perfect square, you got a perfect square, and you could just do this. So let's get into it. I'm going to do it, like I said, I'm going to do it 2 different ways. I'm going to pull the greatest common factor out first, right? And then I'm going to see what happens. And then I'm going to do it another way where I find the difference of 2 squares first. All right? So what's the greatest common factor? Now, let me see. I could pull a 2 out because these are both even numbers, right? This has an n term, but this does not. So we know n is not part of the GCF. But these are both numbers that are even, so I could pull a 2 out. Now, because off the top of my head, I don't know what the GCF of 196 and 144 is. I don't know. So watch this. Watch what I do. I'm going to pull a 2 out. Because this is something you could do, if you don't really know. But if you know they're even numbers, you can always pull out 2. If you pull 2 out, then you just got to divide each coefficient by 2, right? So 196 divided by 2, the 100 is going to break into 50. The 90 is going to break into 45. So that's 95 when you put them together. And then the 6 is going to break into 3. So 95 plus 3 is going to be 98. So this is going to become 98n squared. Put your minus sign, because that's a minus sign. 144 divided by 2 is 72. All right, so that's 72. All right, now I still don't know. I still can factor further because these are both even numbers. So let me take another 2 out. Half of 98, 45 plus 4 is 49. But oh, I didn't do this right. You know why? Because we already got a 2. So if we already got a 2 outside, and I factor out another 2, then this is what I got to do. I got to pull out another 2. I got to show that, right? Because this 2 was already there. So if I pull another 2 out, that means I got 2 2s that I pulled out, right? So now I take half of the 98. That's going to be 49 my n squared minus 36. So now I got my difference of 2 squares, right? So this is going to become 4 times the quantity, 49 n squared minus 36, right? So this really, so now I know, I ain't know off the top of my head in the beginning, but now I know that the GCF of these two numbers is 4, right? Because 36 times 4 is 144, and 49 times 4 equals 196. So my GCF is 4, all right? Now, you got to factor completely though, not incompletely, not halfway, right? We got to go all the way, right? No such things as halfway crooks. You got to go all the way, factor completely, all right? So we got to factor this, right? It's the difference of 2 squares because that's a perfect square, that's a perfect square, and that's a minus sign. So we're going to pull the 4 down and set up 2 sets of parentheses, right? Now we take the square. Now with the dots method, all you got to do is take the square root of each term. So the square root of this is 7n. So you write the 7n in 2 places. The first slot's in the binomials. Then you take the square root of 36, which is 6. Put the 6 right here, put the 6 right here, give 1 a plus sign, give 1 a minus sign. And now we have factored this completely. We have factored this completely. All right, that's your final answer. All right, now, but notice what I did. This method is like the traditional way that I show students how to do it. Pull the GCF out first, and then see if you could do the dots method if it's a binomial. All right, now let's try to do it again. Watch this though. This is already a difference of 2 squares. So I ain't have to pull the GCF out first. I chose to. I ain't had to do that. I chose to do that. All right, so watch this, right? I know this is a perfect square. I know this is a perfect square. I know n squared is a perfect square. So I can go straight to this step with the 2 binomials. And I can say, okay, this is the square root of this is 14n. Because I know 14 times 14 is 196. I highly recommend if you don't have your perfect squares memorized from 1 times 1 up to 25 times 25, memorize them. Do yourself that favor. All right? It's going to come in handy, I promise you. So 14n goes in the first slot, and another 14n goes in the other first slot. Then you take the square root of 144, which is 12. So you put the 12 right here, and the 12 right here, make 1 plus and make 1 minus. All right? Now we just factored it using the dots approach, or the difference of 2 squares method, right? Somebody might do this and be like, all right, I'm done. On to the next problem. But you're not done. You have not factored completely, because this expression has the GCF, and this expression has the GCF, because these are both even numbers. So the greatest common factor between 14 and 12 is 2. So you got to pull that out, because we factor in completely. We're not factoring incompletely. We factor in completely. Your instructions in your textbook probably going to say, or your online resource are going to say factor completely. All right, so we're going to pull the 2 out. So now we got 2 times 7n plus 6. Where does 7n plus 6 come from? It came from here. Once you pull out the GCF, you got to do division. You got to divide each term by the GCF. So you got to know that 14n divided by 2 equals 7n. You got to know that 12 divided by 2 equals 6, right? And you know this is correct because if you distribute, you're going to get back to what you started with. 2 times 7n is 14n. 2 times 6 is 12. So that's proof that you did it right. But then it's the same thing, right? Except for the minus sign. So what you're going to do is you're going to pull a 2 out of this one right here. You're going to pull a 2 out of this binomial right here. And do the same thing. Then you're going to divide. You're going to have 7n, except now you're going to have 7n minus 6, right? So now you got 2 times the quantity 7n plus 6 times 2 times the quantity 7n minus 6, right? But you could clean this up a little bit. You could take these 2's and put them together, right? Multiply the 2's together and make them into a 4 out front. So now you got a 4 times the quantity 7n plus 6 times the quantity 7n minus 6. And that's another way to get the answer. So I want you to understand that you always got options. You always got options, you know. You're not locked in, right? So what I say is sometimes you might want to pull the GCF out first, right? and then see if it's a difference of two squares and use that method. Or sometimes if you see up front from the rip that it's a difference of two squares, you might just want to go in and just factor it that way, because you know what's going to happen. Your number's going to get smaller. You see how the situation we ran into where I didn't know the common factor between 196 and 144. So I had to just start playing with twos. I just start pulling them twos out because I know they're even numbers, and that's the definition of an even number. Every even number is divisible by 2 with no remainder. So I had to start playing with them twos, and then I had to keep going. I had to do it again. And luckily, we got to the GCF, which was 4, right, that we needed. But if we had did it this way, it's much easier to deal with a 14 and a 12 than it is to deal with a 98 and a 72, or a 196 and a 144. So again, that's why it's important to have options. So definitely embrace the options, understand the options, understand that there are multiple ways to do these problems, all right? So definitely go get some practice, ask your teacher, ask your professor, or just do an online search for practice problems using the difference of two squares method. Inevitably, you will see problems like this where you have the option, right? We have the option to either pull the GCF out first or use the difference of two squares method first. All right, so you go get some practice. Do some research on Fisk University out in Nashville, Tennessee. Shout out to them. If you're not familiar with it, or if you are familiar with it, do some more research on it. And check out that book, The Education of Black People by W.E.B. Du Bois. All right, I'll see you on the next video. Peace.